Hey, second graders. Today we are going to be learning more about forces, in particular gravity. So let's go ahead and get started. All right, guys, let's dive into gravity here. So, what is gravity? Gravity is a force. Gravity makes everything fall towards the earth. All objects have gravity, so not just the earth. But some objects like the Earth or Sun have a lot more gravity. Gravity depends on how big an object is or on the mass of the object. So why is gravity important? Without gravity, guys, we would fly off of the Earth, and I'm pretty sure none of us want to do that. Gravity keeps the Earth rotating around the Sun. Because the sun is bigger than the earth, which is this tiny little dot right here, you can see close up that that's the earth compared to the sun. The sun is massively huge. It has more gravity. The sun has more gravity than the earth. It pulls on the earth rather than the earth rotating around it. However, both the earth and the sun pull on each other because they both have gravity. Without gravity, Earth would fly through space and become a giant ice ball because we need the sun's heat and light to live. And then it also says here, guys, this is a really cool fact. The diameter of the sun, diameter is the middle point of a circle all the way around, is about 109 times the diameter of the Earth. So the sun is massively huge. And it's also comparing it to Jupiter, which is the biggest planet in our solar system. So it's pretty intense there. So when we are talking about gravity, it's important to know who Sir Isaac Newton is. Sir Isaac Newton discovered gravity while sitting under an apple tree. The apple fell on his head and he got the idea to study how objects move. Gravity pulled the apple towards the earth and Newton's head, inevitably. It plonked him right on the head right there. This led to the discovery of how objects such as the Earth and Sun move through space due to gravity. So we kind of talked about it a bit on this last slide. The Sun pulls on the Earth and the Earth pulls on the Sun, but because the Sun is bigger, it has more gravity. So that's why we orbit the sun and not the other way around, where the sun would orbit the Earth. So, weight and gravity. Because weight is a measure of the force gravity has on an object, it's really important to know. So, weight on Earth is due to the Earth's gravity. Because we're on Earth, our weight is fixed everywhere on Earth, but if you went to the moon has less gravity, so you would actually be lighter. So that's why when people walk, you see old photos or pictures or videos of people walking on the moon, they kind of bounce because they're a lot lighter because there's less gravity. So some examples of weight is your weight on a scale. That is the force of gravity on your body pulling you towards the earth. The weight of an African elephant, which is about 12,000 pounds, that's really big. And then the weight of the Great Wall of China, it's estimated to weigh about 116 billion pounds. And I also wrote it out for you guys so you can see just how big 116 billion is. 116 billion is all of these zeros after 116. Okay, so that's like the heaviest object on Earth. So it's massively huge. They can't put it on a scale. I'm sure they had a really good scientific way to figure that out. Okay, so next, guys, we are going to watch a YouTube video. I'm going to cut to that.
If I told you that you just won the lottery, what would you do? If you're like me, you jump up and down and scream. And after you were done freaking out and jumping in the air, you'd land on your feet, right? But why would you land back on the ground instead of just floating off into space? It's because of a little something we call gravity. Gravity is what pulls everything toward the ground, including you. Without the force of gravity, there would be no life on Earth. Air, water, animals, everything would fly off into space. There'd be no you, no me, no French fries, nada. Think of gravity like the invisible superglue that holds our massive world together. You can't see it, but it's always there. An English scientist named Isaac Newton was the first person to seriously study gravity over 300 years ago. There's a famous story about him that you might have heard. Supposedly, Sir Isaac was hanging out underneath an apple tree thinking, probably partly napping, when an apple fell from the tree and conked him on the head. That's when Sir Isaac had an aha moment. Why did the apple fall down to the ground and not up or sideways? He realized that a special kind of force, which we now know as gravity, was acting on all of the objects on Earth, pulling them toward it. Once the apple became too heavy for its stem to hold it anymore, the gravitational pull of Earth brought the apple down onto Newton's noggin. Newton also realized it doesn't matter how heavy an object is either, whether you're holding an apple or a bowling ball or a feather. If you let go of it, that sucker's going down. We're gonna make a whole video about this later. Basically, he determined that what goes up must come down. Sir Isaac was a pretty smart dude. Okay, so you know that if you jump up, you'll eventually land back on the ground. And you know that an apple dropped down will land on the ground too. But what if you throw something in front of you, or to the left, or the right? To see how gravity will act, pick up the tennis ball or any small round object and hold it in your hand. Let's toss it in the air and watch it fall to the ground. No surprise here. Okay, now pick it up and hold it over your head. Let go and watch it fall once more. Again, not a shocker. Now throw it to your left. Fall down. Pitch it to the right and watch it go down again. No matter where you throw the ball, it's going down. So we've determined that near the surface of the Earth, where we all are, gravity is the cause that produces the effect of all unsupported objects falling down. The ball will go up or to the left or to the right for a little bit, but eventually it's going to be pulled back down to the ground no matter what. Gravity's got a hold on, well, everything.
That was a really good video. It does a great job of explaining how gravity works. You know, what goes up must come down. That's a great way to remember how gravity works. So now that we've learned about gravity and weight, let's think about how objects fall. Do all objects fall at the same speed? This is going to be what we think about when we do our next project. What if they have different weights? Is that going to affect the way they fall? So let's do an experiment to find out. So I am going to actually demonstrate this for you guys. You don't need to read through all this quite yet. When you do it on your own, you will have a worksheet. So I'm going to show you what I'm going to do. Okay, so guys, the next step is going to be to grab one of your objects and weigh yourself with it. I'm not going to show you me recording all of that and actually weighing them, but I will show you the math. All right, guys, I'm going to find three objects around my house that I can weigh. So let's do that. Okay, so I have decided to weigh my yoga mat, this dictionary, and this kitty. Let's get started. Okay, so I weighed myself, and it's kind of fluctuating a little bit. So we're going to say that I weigh 236. Okay, so as you guys can see, my yoga mat with me and the yoga mat, the total weight was 238. The book was 237 when I was holding it, and me. And me and my cat together weigh 245 pounds. Okay, so next we're going to do a little bit of math. I'm going to show you how to do it with the yoga mat here. So what you're going to take is you're going to take your yoga mat weight, which is 238, and you're going to minus your weight. Minus 236. So once I minus that all out, I simply just get 2. So these cancel out, and 8 minus 6 is just 2. So we can see that my new weight for the yoga mat, is 2 pounds. Okay, so I forgot to mention LBS. That is the shorthand for pounds. That's how we would, rather than write out the whole word pound, we can just put LBS. So my yoga mat was 2. The book weighed 1 pound. My cat weighs 9 pounds. So now what you're going to do is you're going to decide whether or not these objects are going to fall at the same speed or if they're going to fall at different speeds. If you think they're going to fall at the same speed, you can simply just put 0 for all of them, because we're just going to assume, we're going to predict that these all fall at the same speed. Now, if I wasn't sure on that, if I thought, hey, these objects are going to fall at different speeds, I'm going to simply put 1, so we're going to rank them 1 through 4. So 1 is going to be the fastest and 4 would be the slowest. Now I only have 3 objects, so I'm only going to do 1 through 3. So I'm going to say the cat's going to fall the fastest because she's, the chunkiest. So 1, I'm going to say the book next because it weighs 2 pounds, which would be the next heaviest. And 3 for the book because it weighs the least, so I think it's going to fall the slowest. So now what I'm going to do is I'm going to test these, and we're going to see which one falls the quickest. So you can't quite see it, but I have a stopwatch on my phone here. I'm going to hit start when I start to drop my object, and then once it hits the ground, I'm going to hit stop. So this is 1 second, and this is a decimal. So if you aren't comfortable with decimals, you can just write 1 second, and that's okay. So I'm going to drop on camera all 3 objects, and we're going to see the fall time. First, we got this one. I'm going to drop her from, I'm going to try to do the same height so our results are the same. So I'm going to drop her from about right here. She's not going to be too happy with me, but she'll get over it. So let's start. I'm going to go in 3, 2, 1, and go. All right. That was 1.33 seconds. So not quite a full 2 seconds, but just over a second. Let's do the next object. All right, so next I have my yoga mat, and I'm going to drop it from about the same height. And again, I'm going to use my timer to time how long it takes. So we're going to hit start, stop. So that one was also about the same time, about a second, so really close to each other. And last, I have this book. My neighbors aren't going to be too happy that I'm dropping stuff on the floor that live below me, but hey, it's part of the job. So let's drop this book and see how fast it falls. So we're going to go from about the same height. We're going to drop it in 3, 2, 1. That one was also about a second. That's how long it took. I'm not going to go through the rest of this. I really want you to sit down and think about your experiment, what the results are telling us. The thing that's going to be the biggest indicator is going to be our fall time, okay? There might be a little bit of difference, but that's for you to find out. So good luck with the experiment. At the very end, I want you to write about how your thinking may have changed, what changed about your theory. If you're still a little bit confused by the results of the experiment, there is a little bit at the end of the worksheet that explains what is happening. Even if you feel like you did a really good job and it all makes sense, it's still a really good thing to read through just to refresh your memory. So good luck experimenting, guys. I'll see you later. Bye.